If normal voltage is applied to a squirrel cage induction motor for starting, a very large initial current to the tune of 5 to 6 times the normal current will be drawn by the motor. This will in turn affect the other electrical equipment connected to the same line. This initial rush of current is controlled by applying a reduced voltage to the stator winding during the starting period, and then the full normal voltage is applied when the motor has run up to the speed. To start and stop the motor and to prevent it from overload currents and low voltages, a starter is required in the motor circuit. And that's what we are going to learn about in this exercise. The different types of starters used in squirrel cage induction motors are direct online starter, star delta starter, step down transformer starter, and auto transformer starter. In this exercise, we are going to identify the parts of a manual star delta starter and trace the connection. Draw the star delta connection of motor winding. Provide backup fuse in the main switch of the 3-phase squirrel cage motor. Connect the manual star delta starter with 3-phase squirrel cage induction motor. Start the motor through the manual star delta starter. The tools required for the purpose are insulated cutting plier, a screwdriver, side cutter, wire stripper, ammeter 10 amps, voltmeter of 500 volt range. First, gather all the details possible from the induction motor and the starter and enter it in the table. Manufacturer, rated frequency, model, rated power, type of current, function, serial number, type of connection, rated voltage, rating class, insulation class, rated current, rated speed, protection class. Switch off the mains and remove the fuse carriers. Remove the terminal cover of the motor and the front cover of the starter. To connect a star delta starter, the squirrel gauge induction motor must have 6 terminals, which are normally marked as U1, V1, W1 and U2, V2, W2. Identify the parts of the star delta starter. Trace the connections and draw the traced out circuit. Make the connections of the motor and starter as per the diagram. Connect the 3 main supply cables to L1, L2 and L3. Insert an ammeter in series with one of the line cables from the main switch and the voltmeter across the 2 line cables. Insert the fuse carriers with proper fuse in the main switch. Switch on the mains power and observe the voltmeter reading and move the handle to star position positively, and at the same time observe the starting current and enter it in the table. Allow the motor to start, run for some time, and let the sound of the rotating shaft come to a steady state. Then move the handle to the delta position positively. Note down the direction of rotation and enter it in the table. Note down the current drawn by the motor in running condition and enter the value in the table. Then stop the motor by pressing the stop button on the starter. Switch off the main switch and remove the fuses. Interchange the 2 line cables R and Y to terminals L2 and L1 as in the diagram. Insert the fuse carriers and repeat the recording process again. Stop the motor, switch off the supply, remove the fuse, interchange the line cable Y and B to terminals L3 and L1 as shown in this diagram. Insert the fuse carriers. Repeat the recording process again and record your reading. switch off the mains, remove the fuse carrier and remove all connections. Probably you now know the necessity of a starter in a three-phase induction motor, the procedure to connect a manual star-delta starter in line with the motor, and make note of the readings. This brings us to the end of this module, in which we dealt with the rewinding procedures for various types of motors. Motors burn out for a reason. It is usually important to figure out why a motor burnt out originally. If you don't figure that out and correct the cause of the burnout, the new winding will also burn out for the same old reason. So, please do the failure analysis properly before taking up a motor for rewinding. Thank you.